to Algebra 1, Chapter 6, Section 6, Solving Systems of Linear Inequalities. First question, only one of these is a system of equations. Can you choose which one? If you chose the third one, you are correct. So how can you tell if an ordered pair is a solution to a system of equations? Well, if it's a solution, that means every equation in the system will be a true statement when the ordered pair is put in place of x and y. Vocabulary word is boundary. A boundary is something that divides one item from another. So this is our boundary line dividing our solution set versus our non-solution set. Now, as we talked about in the last video, our solution set is included in the boundary line if it makes that statement true, which means it has a greater than an equal sign or less than an equal sign. If our boundary line is dashed, that means it has a less than sign or greater than sign without the equal sign, and our solution set does not work. Complete each sentence, and we're going to use bounds, boundary, or border. The landscaper planted a border of flowers along the sidewalk. The ball bounced out of bounds. The boundary line on the map between the countries is shown. And in the final question, we are to circle the ordered pair that is on the boundary. Now, on the boundary means it's going to make this a true statement. So which one of the following make that a true statement? Remember, you're going to put the first number in for x and the second in for y. Well, if you put 6 in for x and -1 in for y, you have -1 plus 2 is less than or equal to 6 minus 5. So 1 is less than or equal to 1. Since 1 is equal to 1, it is on the boundary line because it states the equation for the boundary line. And system of linear inequalities. A system of linear inequalities is a set of two more linear inequalities given at the same time. When you find the solutions to a system of inequalities, it will include ordered pairs that work in all of the inequalities in the solution set. Let's graph this system of inequalities and see what it looks like. The first inequality has a greater than or equal to sign, so its boundary line will be solid. The second inequality has a less than and equal to sign, and because of the equal to, it will also have a solid line. We need to write both equations into slope-intercept form. The first one is already in slope-intercept form. The second one, we need to add 3x to both sides to get it in slope-intercept form. So it will look like y 3x minus 4. Let's go ahead and graph these. Now looking at this, we need to determine which side of each line is shaded. So on y equal to -x plus 5, I'm going to put in the point 0, 0 and see if that makes a true statement. So would that be a true statement? No. So the other side, the side not including 0, 0, is shaded. Let's do it for the second equation. Put in 0, 0. Is that a true statement? Again, 0 is not less than -4. So again, I will shade the side opposite the point 0, 0. Now our solution set is this set right here. This set that is shaded both red and blue and has the boundaries of these lines. So this is our solution set. It's a set that's true for both of them. Let's write a system of inequalities from a graph. So we're looking at this graph, and the first thing we're going to focus on is this red line. That's a dashed line. And we need to determine the equation of that dashed red line. So can we tell what our b is? Our b is going to be a positive 1. Do we know what our slope is? Our slope is a rise -1, so it's -1 over, and a run 2. So it's 1 over 2. Our line will be -1/2 x plus 1 using y equals mx plus b form. The shaded region of that red line is below the line. and the boundary line is dashed. Since we know it's dashed, the inequality must be a greater than or less than sign, so we will not use these two. So our equation for the red line will be y, and it's below the line, so 0, 0 is included. So if I put 0, 0 in for my x and my y, would this be a true statement? And it would. So I know I've gotten the right one. Now let's look at the blue line. Our y-intercept here is again 1, and our slope in this case is -1 if I go down, -2. So our slope is -1 over -2, or +1/2. So our formula will be 1/2 x plus 1. The shaded region is again below the line. So in this case, the boundary line is solid, so I will not use these two. I will use the less than or equal to and the greater than or equal to sign. So I need to determine which one. So I have y, 1/2 x plus 1. Now if I put 0, 0 in there as a point, and in this case I know the point 0, 0 works, I have to make it a true statement, this line would be this way. And again, it has an equal sign because it's a solid line. So those are the system of inequalities represented by this graph. To solve by graphing, there are 3 basic steps. First, put each equation in slope-intercept form. Second, graph each inequality in the coordinate plane, and you can use the slope-intercept form to do that. Third, shade the intersection and the overlap of all inequalities, and we've done that using the point 0, 0 as a test point. Now, if point 0, 0 is on the line, you must pick a different test point. Our system of linear inequalities has 3 equations. Let's graph each of these equations and see what they look like. Y is less than 2. Our symbol does not have an equal sign included, so it'll be a dashed line, and it'll be a horizontal line where y equals 2, which will be right here. Now, our point 0, 0 is not on the line, so if I use point 0, 0, would this make this a true statement? Is 0 less than 2? It is, so this side of my graph is shaded. Now for the second graph. X is greater than or equal to 1. This does have an equal sign included, so I will draw a solid line where x is equal to 1. Again, point 0, 0 is not on the line, so I'll test that. Is 0 greater than or equal to 1? It is not. So I'm going to shade the side opposite. So my side opposite is over here. Now in blue, I will graph the last equation. I have a slope of 1 and a y-intercept of -2. I'm going to find my -2. I'm going to go up 1 over 1, up 1 over 1. And create a line that goes like this. And again, I'll put in the point 0, 0. So 0 is greater than 0 minus 2. And of course it is, so I'm going to shade the side with 0, 0. So my graph is the side of that all of them are shaded. Well, if you look, the only part of these that are all shaded is this little part right here is the part that's all shaded. So that is my graph. Five, four, three, two, 1, and as you can see, I have plotted the 3 points that are asked for, and I've drawn lines through these. So to write a system of linear inequalities that defines this section in here, I need to find the equations of each of the lines. And to do that, I'm going to use slope-intercept form. The green line is probably the toughest, so let's start there. Looking at the green line, my intercept, as you can see right here, is 1, 2, 3, 4, 5, 6, 7, 8, 9. And my slope is rising 1, 2, 3, 4, 5, and running 1, 2, 3, 4. So my equation there will be y something 5/4 x plus 9. Now the reason I said this something here is I know it's not an equal sign, but I do know an equal sign will be involved. So it's going to be greater than or equal to or less than or equal to. To determine that, I'm going to look at the point 0, 0 because it's not on a line. If I put 0, 0 in here, what would make this a true statement? And it has to be true because that side of my green line, this side is the side that's shaded. So the 0, 0 would be the shaded point. Well, for that to be a true statement, it needs to be a less than or equal to sign. So my equation has less than or equal to in it. The next line we'll look at is the blue line. Now the blue line has a y-intercept of 0 and it has a slope of rising 1, 2, 3, 4, 5, but running a negative 1, 2, 3. So this will be y something negative 5/3 x. Now this line goes through point 0, 0, so I cannot use that as my test point. I need to pick something else. So I'm going to pick the point negative 2, positive 2, this point right here, because that's clearly on the side that's shaded. So if I put that in, 2 something, negative 5/3 times negative 2, this would be 2 something, 10/3. Of course, that will go this way. So that will also be less than or equal to. So far I have two of my equations. Now let's take a look at the red line. That is a horizontal line. So that is y something along the 0 axis. Now once again, I can't use the point 0, 0 because it's on the line. So I'm going to pick the point negative 2, 2 because that line is clearly on the side that's shaded. So my y value is 2. 2 something 0. What would make that a true statement? Greater than or equal to. So my third equation is y is greater than or equal to 0. And those are the three equations that define this polygonal region. Well, it's time for your lesson check and your math success. Please do both of these and bring any questions you have with you to class tomorrow.